So this is a trigonometry question, and I've got arctan 2, arctan x, and it equals this, and I've got to find the values of x and x, z plus. That means it's an integer, and in fact a positive integer. So the first thing I need to do is I need to think about what particular identities I'm going to use here, and I've got this one here, which is the compound tan angle identity. So the reason I'm going to use this is I'm going to actually take a tan of both sides. So I'm going to take a tan of arctan 2 plus arctan x. And that's all in a bracket. I'm taking a tan of both sides. Now I can't take a tan of each individual thing. I cannot multiply out this bracket. That's against our algebra rules. So we've got tan 3 pi over 4 on the other side. Now I actually know the answer to 3 pi over 4 because that's going to be minus 1. It's in the second quadrant and it's the equivalent of pi over 4. So in here, I'm going to treat this as my a value, and I'm going to treat this, well, actually not a, but actually that's a, so it's going to be tan a, so it's going to knock out the arctan. This is b. So what's happening here is I'm going tan a. So it's tan arctan 2. So what we finish off with here on the left-hand side is 2. Because it's a plus, I'm going to use a plus here, plus x, because it becomes tan arctan x. I'm going to divide all of that by 1 minus, so we've got the minus there for the plus. Tan a is 2, and tan arctan b is x. And like I said, this one over here, this just becomes minus 1. Now, we're just going to multiply both sides by that denominator. So we have 2 plus x equals negative 1 plus 2x. Take x from both sides, add 1 to both sides, and we're finished. A very straightforward solution if you can identify this part here, taking the tans of both sides and recognizing that the tan arctan 2 is just going to be 2, your value of a.